Okay, guys, we're going to finish up this chapter with the algebra review. We're just going to simplify radicals, which we've obviously done over and over and over and over and over again this year as well as last year. And so hopefully by the end of this, you'll be able to get this down. Because next chapter, in chapter 9, you're going to have to do a whole lot of radicals with Pythagorean theorem and things like that. So pay close attention here. So we're going to simplify this radical. First, we got to just break it down. Okay, remember the way we break it down is we think about what is the smallest perfect square that is a factor of 75. So you kind of start going down in your head or going up, however you'd like to do it. The way that I suggest is start with the largest perfect square that's less than 75 and test them out until you find one. That way you don't have to do it more than one time. Okay, so we'll start with 64. That obviously doesn't work. Neither does 49, neither does 36, but 25 does go into 75. So we could rewrite square root of 75 as square root of 25 times the square root of 3, since 25 times 3 is 75. Now, we all know that square root of 25 is 5, so the answer to this is going to be 5 square root of 3. Okay, that's a review from what we've done in previous chapters for algebra review. Now we're going to start doing other stuff with it, so we're going to add, subtract, multiply, divide, square, things like that with these radicals. So this first one is just simple adding and subtracting. The thing about radicals is you can only add or subtract radicals if they have the same number on the inside of the radical. Okay? None of these do, as the way they're written. So what you need to do is you need to see, can you simplify one of these and break them down so you can add or subtract them. 5 you can't do anything with, 3 you can't do anything with, but square root of 20 you can break down. Alright, so same method, try to figure out how to rewrite that. So the square root of 20. Biggest perfect square that's less than that is 16. 16 does not divide into 20 evenly, so that's not going to help us. 9 doesn't either, but 4 does. So this is square root of 4 times the square root of 5. And we all know the square root of 4 is 2. So what I'm going to do is I'm going to rewrite square root of 20 as 2 times the square root of 5. So we've got square root of 5 plus 2 times the square root of 5 minus square root of 3. Okay, now you can combine those square root of 5s. You can add those up. Right? Since there's no number in front of the square root of 5, we assume it's a 1. So 1 square root of 5 plus 2 square root of 5 is going to be 3 square root of 5. And the square root of 3 you can't do anything with. So that would be the final answer to that problem. Alright, multiplying these things, you literally just multiply the inside of it. Okay? So we can multiply straight across the way it is. We've got 27 times 3, which is going to be square root of 81. Okay, and we know that the square root of 81 is 9, so that is the answer to that problem. Okay, now squaring these. So we've got 4 times the square root of 13 squared. Basically, the best way to do this, if you have a coefficient on the outside, okay, best way to do it is going to be thinking of it as distributing that squared. It's going to have to go to both the 4 and the square root of 13. So 4 squared is 16, and square root of 13 squared is 13. Okay? A square root of anything squared, the squared and the square root are just going to cancel each other out, and you're left with the number on the inside. So 16 times 13 is going to be the answer, which is 208. Alright? Complicated ones. Alright, we're going to do a couple of them where you're dividing radicals, okay? Now in this class, you're not going to be able to have any radicals in the denominator of any answer, okay? You're always going to have to what we call rationalize the fraction, or rationalize the denominator. Alright, we don't want any radicals down there. So, in order to rationalize this, what you're going to do is you're going to take whatever the square root that's on the bottom here, and you're going to multiply the whole fraction by that square root over itself. Okay, the reason you could do that is because anything over itself is just 1, and if you multiply anything by 1, it doesn't actually change the number, it just changes the way it looks. So, when you multiply straight across here, we're going to get 10 square root of 5 on top. And square root of 5 times square root of 5 is the same as square root of 5 squared, which I said is going to cancel out that square root, and you're just left with 5 in the denominator. Okay, then you can simplify the fraction. we got to reduce 10 over 5. 10 over 5 is going to reduce to 2. So the answer will be 2 square root of 5. Now the next one. There's a couple different ways to do this. I will show you. You could just multiply by square root of 8 over square root of 8 and then go from there. All right, but I would actually suggest, I think it's probably a little bit easier to reduce that radical first, and then we'll work from there. Okay, so you got to think about how to break down square root of 8. Well, square root of 8 is the same as square root of 4 times 2, and square root of 4 is 2, so it's 2 square root of 2. Okay, now if you had something like this, where we've got a number down here, a number and a radical, all you got to do is multiply by the radical part. You can just leave that root 2 down there, and we'll mess with it later. Okay, so we'll have square root of 2 over square root of 2. Okay, so on top we're left with 7 square root of 2, and on bottom we've got 2 times root 2 times root 2. Once again, the root 2 and the root 2 is just going to become 2, so we'll have 2 times 2, which is 4. And that will be the answer to that question. Now the last type of thing we'll have to do is just solve these simple equations with a squared in there, so we're going to have to reduce radicals by the end of it. Alright, so for this one, number 7, we've got 3x squared plus 2 equals 20. Well, we're just going to try to get x by itself. So you do it in the same fashion as you've always solved equations. Okay, we'll subtract the 2 from both sides, left with 3x squared equals 18. Divide 3 from both sides. We've got x squared equals 6. Alright, but this last step is we got to take the square root of both sides to make the squared go away. Okay, so x is just going to be the square root of 6. However, one thing about taking the square root of something in an equation is your answer is always going to be plus or minus. Okay, so x is going to be equal to plus or minus the square root of 6. Okay, that's a general rule you'll have to remember. This plus or minus is really important. You've got to have that in there at all times. Okay, the reason for that is because plus square root of 6 times plus square root of 6 is going to be equal to 6, but also minus square root of 6 times minus square root of 6 is also going to be equal to 6. So it doesn't matter if it's plus or minus. When you square something, it's going to come out positive, so that's why you need the plus or minus there. All right, one last example for those types of problems. We're going to get x by itself again in number 8 here, so we got to add the 11 to both sides, and we'll have x squared equals 32, square root of both sides. Those cancel out, and we've got x equals plus or minus square root of 32. You got to test to see if you could break that down at all. Okay, so the biggest perfect square that's less than 32 is 25. That does not divide evenly into 32, but 16 does. So we can rewrite this as square root of 16 times square root of 2, because 16 times 2 is 32. Square root of 16 is 4. Leave the root 2 there. The plus or minus still has to be there, and that is what x equals. You're all done, guys. Come into class, get ready to work.